All right. Okay, step number 2, motors. Motors. Okay, so we're going to go ahead and start an overcome protection device. Overcome protection device. This is still on. Okay. All right. My overcome protection device. Come on, buddy. Let's move you out of the way right in here.
Just hit the little line and sing it
Okay.
over on your thing.
My overcome protection device, if you guys, I have a couple of motors with an overcome protection device and an overload and a Mr. motor. A couple of them. Anybody has a problem with that? Overcome protection device. Another motor, overcome protection device, overload, and a motor. And a third one, overcome protection device, overload, and a motor. Okay, I have 4 motors connected to the same feeder, tabbed from the same feeder. Just to give you an idea how this is drawn, this will be tabbed. All these big dots are tabbed. So since I don't want more tabs over here, just tab it right in here. And then this will be my gutter. You guys remember the gutter? The black is equipment. This is my gutter. This device will be in a different panel. This is panel number 1. Okay, and all this would be magnetic starters. Each one of these will be magnetic starters sitting in a wall. So that will be magnetic starter number. Let's start from left. That will be a 4. Magnetic starter number 3. Magnetic starter number 2. And magnetic starter number 1. 4 magnetic starters connected to a gutter through cables and fed from a feeder, right? And we need to size the following. Everybody knows what the equipment is. The black is an equipment. Black is equipment. So as you know, this is another equipment. A third. These are all equipment. Anything in black is equipment. So these are different, separate pieces of equipment. All the blacks are separate, different pieces of equipment. The red is the wiring, how the wiring is connected. So Brad, how do you think you connected this box into this gutter? Through a conduit and a wire. There will be a conduit and a wire, right? Or a cable. Most likely it's going to be a conduit, EMT conduit and wires. So between all these boxes, there will be conduits and wires, okay? And our job is to do the following. Size these wires, and we can size the conduits, but today we're not interested in the conduits, we size them. We're going to size the wires at least. And we're going to size the disconnect, overcome protection device, overload, and branch circuit conductors and feeder conductors. So I'm going to go label them. So let's label them. And they're going to be the same for every one of them, guys. I'm going to call the, let's start with top to bottom. Let's just start top to bottom. Let's start with the disconnect. The disconnect, I'm going to call the disconnect number 1. That's a disconnect. I'm going to call the overcome protection device number 2. And everybody knows where I'm pointing here. This is pointing to this. And I'm going to call the overload here. My overload, I'm going to call it number 3. Okay? And I'm going to call the cable. The cable here is number 4. The cable, I'm going to call it number 4. This may be a little bit confusing here. I hate going back and to draw things. There you go. There you go, Chad. You're getting good at it. Number 1. Number 1. Number 2. And is number one is a disconnect. Number two is an overcapacity device. It's even worse when you write it. There you go. I don't need that one. Okay. 1, 2, 3, 4. Everybody's following with us? What's the first number one? Number one is disconnect. Number two is overcapacity device. Everybody knows what a disconnect is. A disconnect is something similar to that one, and we use it always. Isolate the system, lock it, tag it, and work on it. That's it. That's a disconnect. Overcapacity device is one similar to the ones in the panels here. If you guys look, a fuse or a circuit breaker, and we use it to turn the power on and off. Number one, and we use it to interrupt the circuit in case of a short circuit or a ground fault. Okay, cool. What's a conductor? The conductor is a conductor connecting, bringing the power to the device. Number three is the overload. The overload, guys, is a specially designed device for motors only, to trip in case of overloading a motor. For example, you have a pump that's designed to pump water 2-story, and you go install this pump to pump the water 4 stories. So what do? You put a lot of load on that pump. It has to pump it higher, so it's going to overload. It's not short circuit, it's not ground fault, it's overload. Another example, if you have a conveyor with a conveyor belt that's supposed to handle 50-pound load, and you went and you put 100-pound load in it, or a lift that's supposed to electrical lift that's supposed to lift 100 pounds, and you went and you put DJ here, my friend, in it. Would that be a big deal? It's gonna overload it, right?
Okay.
So a little bit. So any question is about what we're pointing to. The second thing I'm going to point to is here. Oops, here. Use the same connection. This is number, where are we? Number 5. And this one will be number 6. So 6 things I need to calculate. 6 things I need to calculate. Anybody has any problem with that? Any question? So what is number 5? Number 5 is the feeder that feeds these 4 motors. Number 6 is the overcapacity device that protects these conductors, the main conductors. All right, let's put horsepowers in these. Let's put a couple of horsepowers in these, right? We can't calculate without horsepowers. That wouldn't be fair, would it? So we're gonna go and put a couple of horsepowers on these motors, and to make it realistic, I'm gonna go and get my horsepowers from. I want to have 1, 1.5, 2, and 3. I want to have 1, 1.5, 2, and a 3. This is 1, 1.5, 2, and 3 horsepower motors. Anybody has an issue with that? 1, 1.5, 2, and 3 horsepower motors. These are horsepowers. Horsepower, 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 horsepower. The system voltage is 240 volt, single phase. The system is 240 single phase system, 240 volt single phase system. Anybody has an issue with that? 240 single phase system. 240 single phase system. If it was a 3-phase system, we're going to go to just a different table, same calculation, which we will be doing in the commercial more often. Any question guys about the system? Everybody knows how the system is set together. Why would you do something like this, guys? There's a couple of pumps in a wheelhouse, and you bring a feeder there, and the pumps are sitting there pumping water from a wheelhouse somewhere else. That would be a great application. You bring a feeder into a gutter, tab the feeder. How do you tab a feeder? Special lugs, you go into the feeder here and you tab it into it and feed all these loads. Why do we use a system like this? Cheaper. What's the alternative of using this system? Is to use a panel, and each one of these disconnect overcapacity devices will be residing physically, mechanically inside the panel. It will be a cheaper design. What did I save here by doing this? I saved a panel. If it's single phase panel, you're talking about $200, $300. Any question guys about that? So this is where the overcapacity device is sitting in a panel like this. Everybody knows what the scenario is, right? Before we start sizing. Okay, now I'm going to start. You guys are going to tell me, because I want to go to the next page, you're going to tell me which one, and then we start sizing them. Going to the next page, I'm going to draw the following. I'm we'll draw this table. Oh, come on. We'll draw a table. Do my calculation. I want to say this is M1, M2, M3, M4. And what was the horsepower? 1, 1.5, 2, and a 3. We know what the voltage is. And I want to start calculating for each one of these systems. For each one of these systems, I start calculating, and we keep going with the calculation. Okay, so I'm going to start calculating number one. What was number one, guys? Number one is a disconnect. A disconnect is used to completely physically, mechanically isolate the system, bring it to a dead, complete dead, so we can work on the system. Okay, a disconnect. The disconnect, so over here, what I want you guys to, go this one, what I want you to put here as NEC code. NEC code or NEC article. Just NEC would be enough for you guys to understand. It's an article, NEC. So you don't think that Chad brought this information from his grandma. All right, let's start, guys, by finding the first thing you do before I even put the calculation. The first thing you do in a problem like this, before you do any calculation, guys, is you need to find full load current from NEC. That's the first step you do. You need to find the full load current from NEC. And to find the full load current from NEC, you're going to go to table 430.248. Table 430.248. Can you guys go with Uncle Chad to table 430.248? Okay, when you guys are there, who's going to give me the table 240.242 table 430.248. Everybody got the table? Okay, the full load current. Number one, 1 horsepower, 8. Number two, 1.5, 10. Number three, 12. Number four, 17. Anybody dares to disagree with my friend DJ? No? You and your DeWalt. I'm going to contact him, bud.
I hope you do.
Because it's really, send him an email. Offer. Yeah. He forced me to give him an extra credit. Forced me.
I earned it.
Okay, so NEC, table 430.248. Everybody knows how to use this table, guys? The voltage in this table, it says 230. So, Muhammad, my friend, you're going to be confused now. You're going to say, well, Chad, there's no 240. If you look at atop the voltage, it says 220 all the way to 240. You're going to use 230. The range between 220 all the way to 240, you use the amps of 230. Okay? Everybody got that? All right. You guys are cool. All right. Okay, so number one. Now let's go ahead and calculate that. Number one, disconnect. Disconnect for the motor. Disconnect for motor number one. Here's the calculation that we're going to do, guys, for the disconnect. The article that talks about disconnect for motors, you can go ahead, article 430.110, 430.110, 430.110. If you go there, it will tell you to size the disconnect, Brad. You have to multiply the full load current from the NEC by 115%, 115%. That's what it tells you. To size a disconnect, you need to take the full load current and multiply it by 1.15. Where did the 1.15 came from? 430.110. Why do they do that? Safety. They allow you a little bit, 15% extra amps on the disconnect. Okay, so I'm going to take 1.15 multiplied by 8. equal, who's going to give me the answer? 1.15 multiplied by 8. And the same thing here, 1.15 multiplied by 10, and 1.15 multiplied by 12, and 1.15 multiplied by 17. I need two credible gentlemen, or a credible gentleman and a woman. The first one is 9.2. 9. Anything less than 0.5, drop it. 0.5, drop it. Anything higher than 0.5, make it go up. So this is 9 am. 9 am. Next. 11. 11 am. Next. What? 20. 20 am. Last one.
15.
14. This one is, I can't erase guys with that one. 1.15. And this is 12. What's that one? 12? What's the 12?
14.
14. 14 am. And what's the 17? 20? 20. Okay? 20. Okay, now these are the calculated amps. The calculated amps. The calculated amps. Now up to this, guys, this is my calculated amps. You're gonna go to find the actual size of a disconnect. You're gonna go to DeWalt if you have DeWalt, DeWalt, and you're gonna go to 3-12, 3-12. You go to DeWalt 3-12, 3-12 DeWalt, sizes of disconnects. What's the smallest size of a disconnect? Right in the middle of a page, sizes of disconnects. What's the smallest size disconnect I'm gonna load then? 30. 312-312, and this will be a 30 amp. This will be a what? A 30 amp, and this will be a what? A 30 amp. Anybody has a problem with that? And this will be also a 30 amp. All of them are 30 amps. 3-12.
Yeah, it says right in the center, sizes of disconnects.
Sizes of disconnects right in the middle of it. Can you guys see the smallest respected, reputable disconnect that I can buy is 30 amps? Everybody has DeWalt? I love it. DeWalt is going to love me, guys.
Assuming that's printed correctly.
Assuming it's
So how do you
correct.
get to 30?
How did they go to 30?
Yes.
Because my amps are 9,
Yes.
and the next standard is
30.
30.
Okay.
You can go to 60 if you want to, if you want to pay more money.
I do.
You know what I mean? You go to the next standard.
Okay.
Everybody knows, guys, why we went there. Go to next. Go to next standard. From where? Where do we find the standard? DeWalt. Anybody has a problem with that so far? All right, let's go to number 2. Number 2. What was number 2, DJ?
2 is OCP.
Overcurrent protection device. Overcurrent protection device. Overcurrent protection device. Overcurrent protection device is number 2. Okay, overcurrent protection device, for for sizing overcurrent protection device, I have to tell you what type of overcurrent protection device I'm going to be using. I want you guys to go to table 430.52. We're going to go to table 430.52. Everybody goes to 430.52, please. Table 430.52. 430.52. 430.52. Stop, Chad. Okay, overcurrent protection device 430.52. Now, can you guys see that there are multiple options there? You're going to tell me, Chad, hey, what type of fuse or circuit breaker you want? Let's go say a dual element time delay fuse. I single-handedly want to have a dual element time delay fuse. So what type? The type is dual element time delay fuse. That would be great too. Okay, everybody's there? So let's go to number 2, overcurrent protection device. and I decided to use dual element time delay fuse. You can use any fuse. Dual element time delay fuse is very common in motors. Okay, now, Holly, what's the multiplier for dual element time delay fuse, please?
175.
175. Everybody can read this table, guys. There's columns and there's rows. You can go to single phase motors, induction motors, under dual element time delay fuse, cross-reference the column with the row. What do you get? 175. Mr. Erbab, cross-reference the dual element time delay fuse with single phase motors, induction motors, you get 175. Yes, sir.
What is your opinion on, let's say you're an amp over, you're at 21, would you go up to 25?
If you read this table, guys,
You're allowed to, sure.
yes, you're allowed to, unless I know otherwise, I would go up. Unless I do overcurrent protection device coordination, which you guys are going to be doing, until I do overcurrent protection device, I always go up. It's a cover yourself. What recorded you can't see that stuff. Okay, 1.75 times 8. Okay, and then also 1.75 times 10, 1.75 times 12, and 1.75 times 17. And to find the standard, after you go there, guys, to find the standard, you're also going to go to which table? 240.6. To find the standards for them, you need to go to table 240.6. Okay. Anybody can do the calculation for me? Calculation.
14.
So 1.75 times 8 equal 14. The next standard is 15. 15 amp. How would you know? How would I know that the next standard is 15? Where do you go? 240.6. Okay. What's the second one?
17.
Well, hold on there. I don't think it's 14. I think it's 16. So you go to 20.
Is it 16 or?
You multiplied by 9, not 8. You want to multiply by
14.
9 times 1.75.
It's 8.
8.
It's 8.
Why did you
sorry.
Why did you multiply by?
Why did I see 9?
Because the 9
Oh.
is for the,
Oh, for this.
for the mismatch. So
Alright.
he, instead of doing the 8, he did the 9.
You're carry on.
You're
That's
right.
all right. You always multiply by the full load current. Okay, what's the next one? 18 amps. What's your standard? 20 amp. Okay, what's the next one? 21 amp. What's the standard after 21? 25 amp. Okay, what's the last one? Gosh, you guys are so slow.
21.25.
30 even?
119.
What's 190? Where are we here? DJ.
1.75 times 7.
Oh, I thought, no.
What was the 17? 30?
29.7.
Eric?
30.
30 even? 30? What do you do if you hit the jackpot? You stay
Go
there.
to the bar and drink.
30. Okay, other than that, 30. So as we calculate the overcome protection device, Holly, if we don't hit a standard, if you read under this table, it tells you, hey, don't worry. You have 2 options. Remember the 3 options? You go to the bar and cry and drink. Number 2, you custom design yourself a fuse that's 14 amp fuse, or the code allows you to go up. If you guys up, doesn't mean you have to go up, guys. Can I go down if I want to, or if I know that the fuse work good with this motor? Yes, Mr. Rebel.
I understand 14, 18, 21, 30, but what about 15, 20, 25?
15, 20, 25, 30, because these are not standard, because 21 is not standard, the fuse or circuit breaker, you go to 240.6 to find the standard. And all these red numbers are coming from 240.6. All these red numbers are coming from 240.6. Any question, my friends? Okay, what's next, DJ?
3 is overload.
3 is overload. 3 is overload. Now, For the overload, guys, I have to give you some information. For the overload, I have to give you some information. The information I'm going to be giving you, please write this information up. The information I'm going to be giving you for the overload, I'm going to write them right here. I'm going to have 7 here. I'm going to have 9. I'm going to have 10. And I'm going to have 16. All these are name plate full load current. Nameplate full load current. Nameplate full load current. The green ones are given on the nameplate, printed on the nameplate. Nameplate full load current, printed on the nameplate. 7, 9, 10, 16. I just pulled them out of the hat. For this, these are on the nameplate. On the nameplate. Okay? So you need to know that. Otherwise you can't find it. These green ones are what? Nameplate full load amps or current. Okay. The second thing you need to know, guys, you need to know is service factors. A term called service factor. A service factor is how hard can you push this motor. The higher the service factor, the more robust this motor can be pushed. Okay, that's what a service factor is, and they always print it on the nameplate. So if a motor with a service factor 125, 1.25, it's a tough motor. You can push that motor to work harder, means you can overload it. Okay, so let's give you a service factor. If this is, I'm going to make this one service factor 1.15. I'm going to make this one 1.25. And I'm going to make this one 1.15, and I'm going to make this one 1. Oops. I hate it when I write over the same thing. This is was M1, 1, and 1. And what did we say the amps for it was? 7 amp, and
7, 9,
and
1.1.
1. I want it 1. So these service factor. All these red ones are service factor. Everybody got this one, guys? The green ones are full load current. The red ones are service factor given on the nameplate. Given on the nameplate. Given on the nameplate. Given on the nameplate. Service factor given on the nameplate. Okay. Then you're going to go to, for the overload, motor controller, motor overload. For the overload, we're going to go to 430.32. 430.32. You're going to go to table article 430.32 for the overload. Here's what, if you guys read this article, when you read this article 430.32, it tells you the following. If the motor has a service factor 115 or greater, you have to multiply the full load current nameplate by 125. If the service factor is less than all other cases is 150. Go guys to 430.32. You're going to find the following. It tells you if the service factor of a motor is 115 or higher, your multiplier should be 125. All other cases, your multiplier is going to be what? All other cases, your multiplier is going to be what? 1.15. Everybody saw that? Everybody read that? And also there's the temperature rise. If you guys see the temperature rise, motors with a marked temperature rise of 40 or less, temperature rise 40 or less, 125. All other motors, 115. Temperature rises, guys, is how high the windings inside the motor can reach before the motor fails. They make them, they can handle heat inside. The whole idea of overload is to protect motors from heat, because heat create smoke. Smoke burn things, and when the motor is burned, it cannot run. So if you have a fan and the motor is smoking, you don't expect the fan to give you air, right? So if a temperature markers with the motors marked with a temperature rise of 40 or less, 125. In our case, what's my multiplier then? The first multiplier, 1.15 times 8 times, it's going to be times 7 equal. The second one is 1.25 times 9. The third one is 1.25 times 10 and 1.25 times 16. I want to highlight,
Where are you taking?
these are from the
Oh.
green ones. I'm going to highlight the 16, the 10, the 9, and the 7. And I'm going to refer you all the way back to here. Everybody knows where these numbers came from? The circle, the green circled numbers are coming from the nameplate. The only time that you use a nameplate, or one of the times I use a nameplate, is when you size the overload. When you size the overload. Any question, guys, about this? Any question about this? Straightforward, no? So 4 motors. Okay, so what's the calculation? First one is 8 amps. Second one, 11 amps. The third one, 13 amps. The fourth one, 20 amps. Now, do you go up, down on these? You stay where you are. You adjust your electronic overload protection as close to 13 as you can get it. You don't go up or you don't go down. If I can't get it to be 13, what do? You go a little bit lower. You don't go even higher. So for all practical reasons, all what we care about is just leaving him as is. So when Josh goes and set the motor, go to the overcome protection device over here and readjust the overcome protection device slightly until it fits the motor. Nameplate full load current. Yes, sir.
On your motor one, is that 1.25 or
1.15.
Is because it's service factor is 1.
Because the service factor of this motor is 1.
Because its service factor is 1.
Because right there, it's right. Yeah.
If the service factor, guys,
Your service factor for the
it goes 430.32. Yes, sir. Jim,
I answered it. I was asking what
the code 430.32.
I got it.
Okay. Any question, guys? Any questions? Everybody's good? I know the handwriting is not the best, but I can't answer anything. I don't want to erase, because if I erase, it's a mess. I made it work.
6 of one, half a dozen of the other.
Just one half doesn't matter, right? Anybody wants me to read anything? Everybody's good? All right, what's the third one, DJ?
Fourth
Fourth
one
one?
is the cable from
Conductor. Number 4,
conductor.
branch circuit. Branch circuit conductors. 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 Branch circuit conductors, you need to go to 430.22 and 310.16. And don't forget that you're going to go 75-degree column. Here's the rules for conductors, branch circuit. These are motors. We go to 75 regardless of the rules. 75. So I'm going to go to 75. and Article 430.22. If you guys go to Article 430.22, here's what it tells you. It's continuous load multiplied by 1.25. So piece of cake, Chad. So 1.25 times which amp? The full load current from an EC. What would that give you? And the same thing, 1.25 times 10, 1.25 times 12, 1.25 times 17. 1.25 times each and every full load current from the NEC code book. What do you get? The first one is 10 amps. Second one, 13 amps. Don't give me decimals, would you? What's the third one? 15 amps. Fourth one, 21. Okay. Now you're gonna go to which if you say 21 amp cable, people start laughing at you. What are you talking about? I need gauge, wire gauge. How do you convert 21 amps into wire gauge? I hope you know by now to go to 310/16. So for 21 number 10,
14.
these are motors. You're going to go to 75. Let's start with the 30 with number 10. Number 10 is you can't use this to number 12, number 14 anyway. So for number 10 would be what? 14. For number 13 amps, that also will be 14. For this one will be also 14. For the 21, can you guys check the 21? 12. Can I get away with number 14? No, look at 75. Can I? What? It has to be 12. Okay. 12. 14, 14, 12. 14, 14, 12. Number 14, number 14, number 14, number 12, 14. If it's not color coded, it would be a mess. It's mess with a color code even. Let's go grab this boy and put it right in here since you realize every corner of this. Let's grab this and move it all the way up to.
Just hit the minimize the other chat.
Minimize that?
There you go.
But that will make me smart though.
Do it on your computer or
Do it on my computer works. Dude, you are so smart.
I'm just curious, you see in, 310/16, which giving you the red line?
Yes, thank you. 310/16. You got these red numbers from 310/16 under which column though? 75. Why 75? They're well-respected motors. You have to add the word well-respected motors. Now, if you look, DJ, my friend, if you look at the 20 amp here, protecting a number 14. Chad, have you lost your mind? How would you put a 20 amp fuse on a number 14 circuit, number 14 conductor? That's okay. It's protecting motors. Look at this. A 30 amp tied to a number 12. Have you lost your mind, Josh? No. It's okay because it's a motor. Why? Because the overload, look at the overloads. The overload, guys, on this is 20. Cool, protected. 13, cool, protected. 11, protected. 8, protected. The overload is set to protect the conductors and the motors. Yes, who raising his hand? Yes.
I got a question, I get confused between the terminal reading. I mean, obviously, you gotta go to the lowest one versus, like the 75, or which one you rule out.
The
You
rules.
go to the lowest
The
one?
rules for the 310/16, if the 100 or less, you go to 60.
Right,
Number 1 or less, conductor number 1 or less, you go to 60.
right.
Other than that, more than 100, more than number 1, you go to 75.
No matter what.
Except, yes,
The rating.
except for the rating, and number 2, except if you're dealing with motors. If you're dealing with motors, then you can use 75 all the time.
Oh, okay.
That's why we're using 75 all the time. Okay? All right, what's next, DJ?
The feeder.
Let's go to the feeder. Now number 5, is it feeder over computation device or feeder conductor?
Feeder, just a feeder.
Feeder conductor. Feeder conductor. For the feeder conductor, gentlemen and lady,
Excuse me,
Largest FL.
can you excuse me,
Hey, Chad.
Mr. Rebab, you're asking a lot of questions, Mr. Rebab. What's going on here? Come on.
when you say, you go, 10 arms to 310 at 16,
Yep.
under column of 75,
Yes.
I don't have 10 here. I don't see 10.
What do you see?
I see 12.
This is 20.
You see 20 amps, right? 10, but the maximum. Sorry, not laugh, Mr. Rebab, but I've done that many times when I start using it. That's why I'm laughing at myself, believe me. Because you see, number 14 can get you all the way up to 20, right? From the table. And you only need 10. So you need $10, I'm giving you $20. Is that good? You just want to take 10.
I need $400.
This is not riba, Mr. Rebab. Do you see what I mean? You only need 10 amps and number 14 can give you 20. So it's good. See what I mean? And that's the smallest that you can use. Maybe your question is, why can't I use 16 or 18? Because the smallest conductor in any C code book that you can use for power, lighting, and equipment. Not for control though. Control you can use 16 and 18. For power, lighting, and equipment, the smallest conductor you can use since 1897. That rule since 1897, Mr. Rebab, 100 years ago. Still the rule, you can't use less than number 14 for power, lighting, and equipment. Okay? Is it clear? I can see what you found more amps, that's okay. All right, for the feeder. Here's for the feeder, my friends. The feeder, when you size for the feeder, you're going to go to 430.24. Oops, let's use a different. 430.24. And also 310.16 under 75-degree column. Okay? All right, so if you guys go there, when you go there, it tells you that take the largest amp motor. Amp, not horsepower. The largest amp motor, which end up being the largest horsepower motor, but it doesn't have to be. It could be, the amp of a motor could be higher and the horsepower could be lower if you're using single phase and 3-phase motors together, but that's a whole different story. The largest motor amp, what's the largest motor amp? 17. 1.25 times the largest motor amp 17, but in between brackets, plus all the full load current of all the other motors. What are the other motors? 8 plus 10 plus 12. Now, Brad, would I add the 17 again? Would I add the 17 here? 17 is already used there. So you pump the largest motor 25% extra, and you add the full load current of all the others. Okay, if you guys do that, if you do all this, I have the luxury of being able to erase and you guys can't. Okay, what's the
Hey, Chad.
one second, where am I here? 8, 10 plus 12. All this will equal, what's that total?
51.25.
51.25 would drop that one, that'll give you 51 amp. 51 amp.
Hey, Chad.
Yes, sir.
The 17, I'm just trying to, where are you getting that?
This is that one. This 17,
Oh, you're doing 4.
17 is here.
Multiply the highest one.
You
Highest
multiply
one.
the
Yeah, yeah.
highest. Why did they do 17? You multiply the highest by 1.25.
Plus
Okay. If you go to 310.16 under 75, what conductor size you get? Number 6. Number 6. Okay, here's my question for you. How many conductors of this number 6 do you need? It's a single phase. 2 conductors. Single phase 240. What do you need? 2 conductors. Do I need a neutral? No, unless they tell you otherwise. 3 phase and single phase motors, guys, you don't need a neutral for them. If it's 240, you don't need a neutral. 240. Unless they tell you you need a neutral, you send a neutral.
You don't need to ground it?
That's not neutral though. Equipment grounded conductor, it's grounded through the pipe. The assumption is grounded through the pipe. You're right. Now, if it's not a pipe, then I need to pull a equipment grounded conductor. But the assumption is grounded through the pipe unless they tell you otherwise. Okay, the last thing. Shall we take a break? Break? Okay. We have old people here.
Just
Just for the record.
Don't stop it, Chad.
I want to pause.
It paused.
Forgot recording here. Okay, so finding the overcurrent protection device for the feeder, take the largest overcurrent protection device of the system, plus the full load current of all the other motors sharing the feeder, which is an 8 plus a 10 plus a 12 plus a 17, and that will get you a healthy. Eric, my friend, what you doing here? You're supposed to be my calculator, man.
This is the 17 will have a 30.
You take the largest overcurrent protection device of the system. Thank you. The largest overcurrent protection devices of the system. You add to it a full load current of all the others. The full load current of all the others. 8, 10 plus 12. You don't add the 17. You're absolutely right, because the 17 is covered by the overcurrent protection device of it. Anybody came up with the answer? 6-0 even?
Yep.
Gosh, you guys are cool. 6-0. If it's not a standard, always you go down. Why do you go down, Brad? Because there's nothing in this article that asks you to go, that tells you to go up. So you go back to the 3 options. Drink and cry in a bar, custom design yourself a fuse, or go down because you can't go up. So what's the size? What's the size? Then what's the size, guys? If you go to 240.6, we hit the jackpot here, but it should be 60? 60 M. Gail, what do you want from me? 60. Yes, sir.
I think your code reference should be 430.
430.60.
You have 630.
Yeah.
Did you write this here? DJ? What? There's no 430.62, right? Thank you.
So
62.
what is that formula for that one? It's the overcurrent protection device plus full load amps.
Of all the others.
Okay. Okay.
Any question, guys, about this?
Plus full load.
Any question, guys? Any question? I'm going to add one more thing just because it's cool. I'm going to go back, guys. Add number 7. Can you guys go back to the sheet? Can you guys go back to the sheet? Can you go back to this sheet? And I want to add one more one. It's called the controller, number 7. Number 7 would be the controller. This one is number 7. Number 7 is the controller, the box. They size the controller, which is basically the contactor, the magnetic contactor. How do you size the magnetic contactor? The controller, the magnetic contactor. How do you size that? That's what we're going to be learning. Can you guys add? And this applies, Spencer. This applies to each one of them, right? Because do I have one controller for all of them, or one controller for each? One for each. So I have 4 controllers. Can you guys add the controller? Add the controller. So I'm going to go back. Everybody add the controller. Everybody knows that the controller. And I want to go ahead for my my controller. I'm just going to draw a little bit of my my M1, M2, M3, and EC. And to find my controller, this is going to be number 7. Controller. For the controller, guys, and remember that what was the amps? Can you guys give me the amps for these? That was 1.5, 2, and a 3. For the controller, we size them based on the voltage, and the current, the voltage and the horsepower. So here's how we see. It's going to be, this would be then this controller will be 1 horsepower at 240 volt. This will be 1.5 horsepower at 240 volt. This one will be 2 horsepower at 240 volt. So we size them based on a voltage and a horsepower. What's the code reference? Thank you. The code reference for the motor controller is 430.83. 430.83. Code reference is 430.83. Correct me if I'm wrong here. I've never been wrong.
For motor controllers.
For motor controllers. It tells you size it based on the voltage and the horsepower.
Or
83. Does it say? Okay, then for those of you who have DeWalt, I want you guys to go with me to DeWalt 6-4. I want you to go to D and W, that's DeWalt, page 6-4. 6-4, everybody's there? DeWalt 6-4, and we need to size the controller, NEMA rating of AC motor starters in amps per horsepower, phase and voltage. NEMA, we rate the starters based on NEMAs. National Electrical Manufacturer Association, NEMA 00, NEMA 0, all the way to NEMA 9. Are you guys there? Can you see it goes from 00, the bottom, all the way to the top 9? Can you see it's a 3-phase and single phase? And can you see that we're going to go, their voltages? I want you to go to the last 2 columns, and that says single phase 230, 240. Can you guys see 230, 240? Okay, let's look at the horsepower of the first motor. 1 horsepower. What NEMA do I need for 1 horsepower? 00. So that would be NEMA what? NEMA 0, 0. Now how are you guys going to read that? Check. So this is going to be 1 horsepower at 240 volt, and the NEMA for this, let's use this, the NEMA for it is going to be NEMA 0, 0. Okay, let's look at the second one, 1.5. Can I get 0, 0 to get me up to 1.5? No, I exceed the 1, so I need to go to what NEMA? 0 can get me, so this will be NEMA 0. Okay, let's look at 2. Can I get away with 0 NEMA for 2? Yeah. NEMA 0 again can get me up to 2. How about number 3? What NEMA do I need for number 3? 1. Nima. Oh, Chad, where did that go? Oh, this is supposed to be the motor number. Here. There you go. This is supposed to be the NEC code and number 3. This is motor number 4, which is 3. And then from here, it's supposed to be an EC code, okay? So for motor number 3, let me erase that one. How am I gonna? Can you guys write yourself a note here that this motor is actually going to be 3 horsepower at 240 volts, right? We're beating ourselves a lot here. So that would be NEMA. Which NEMA? NEMA number 1. NEMA number 1. NEMA 1 or NEMA number 1. 2 things. Number 1, when we size the controller, we size it based on horsepower and motor. And please add also phase. We know it's phase, voltage, horsepower, and motor, horsepower, and phase and voltage, because these are single phase. And then you go to table DWAL 6-4. It will tell you what the NEMA is. You have Kenneth, my friend, as you size these, you have to tell them it's single phase too, because NEMA 1 single phase different than NEMA 1 3 phase. Single phase. Can I count on you guys to remember that these are single phase? DJ?
Yep.
Thank you. Is your dog single phase or 3 phase? 3. 3? Okay. 3 phase. Any question, guys? Any question? So, really, all what you need to know about motors is right there, this example. We size the branch circuit. Let me just go back to, can I go back 1, 2? If you guys looked, we sized the branch circuit, disconnect, overcome protection device, overload, and branch circuit conductors. Then we sized the feeder, overcome protection device, and also the feeder conductor. And we're good to go. We size also the controller for each one of them. I'm going to take another example, guys, but this time HVAC equipment. And instead of having 4, I want to have 2, just for the, I don't want to do too much calculation, just 2. And for the HVAC equipment, I'm not interested in overload. The only thing I'm going to be interested in is the disconnect, the overcome protection device, and the cable, and the feeder. So I'm going to do very similar for 2 loads HVAC equipment, okay? And it shouldn't take that much because you guys are smarter than smart now. Any question, Mr. Abab? Brooks, my friend, you're so quiet. Scare me sometimes when you're so quiet, man. Okay. Now HVAC or AC, air conditioning motors. Motors, which is basically air conditioning motors, guys, are compressors. They're special type of motors designed to work with compressors. They use the code because they are special, because they work with compressors and refrigeration, and this will cover refrigeration equipment, cover anything that has chilling effect, as in compressors. And you compress the water, compress the refrigerant, and you circulate it to get cold, creating cold. Does that make sense? Refrigeration equipment and cooling equipment. That's what covers it. This article is Article 440, right after Article 430, because they're cousins. The same example, except this time I'm going to have 2 equipments, and I'm only interested in a couple of things, not everything. There is another thing. The only thing I'm interested in is a couple of things. Is my gutter, 2 things. I could have 15 trillion things if I want to. And here's my gutter. Still have a gutter. Still have a panel. Panel. Gutter. Still have a controller disconnect. Controller. I'm interested, guys, for this HVAC equipment. Mostly, all our interest with HVAC equipment, mostly with the disconnect fuse and the branch circuits. And I'm going to be sizing the following. I'm going to be sizing number 1, number 2, number 3, number 4, and number 5. Why do I have to do that little circle and split things up? Number 5. Looks like a 5. There you go. Number 5. Okay, everybody's with me? What are we going to size? Not sizing controller. If you were to size a controller, guys, it's very similar to motors. Controllers and overload, very similar to motors. Controllers and overload come sized with these HVAC equipment. That's why they're not a big of a deal, but we really almost identical to motors. I'm just interested for this equipment of a disconnect, overcome protection device, branch circuit, feeder, conductor, and feeder overcome protection device. Okay. All right, let's, can I switch to the second page? Are you guys, did you copy it? All right, let's go to the second page and do a little table like we've done before. My little beautiful drawn table. Maybe beautiful is overrated, huh? And I'm gonna have my, I'm gonna call it AC1, AC1 and AC2, two of them. AC2 and EC, and since I have two, I'm going to have these two, and then the bottom I'm going to make it for the feeder. The bottom I'm going to make it for the feeder. Okay. Let's have another one right in between them here. So what was the first one that we need to calculate, guys? Disconnect. We're going to have number 1, disconnect. For disconnect number 1,
Do we have to have the full on the answer?
yeah. Let me give you information about this equipment, guys. Because without information about these equipments, you can't go to the code. These equipments, they don't have they have a horsepower, but they come with an information in them. The only thing we need to know about this information is the following. I'm going to say full load amp. This guy came up. This is what a voltage system. This is a 240 volt system. The same thing, single phase. And this equipment came up with a 28 amps. And this equipment came up with a 33 amps. 28 amps and 33 amps nameplate on them. These are come up with the nameplate on them. Okay, 23 amp and 33 amps. Did you guys, and 240, everybody got that one? So, remember this is a 28 amps and this is a 33 amps. Disconnect, for disconnect, single phase disconnect motors. If you go to the disconnect, guys, 440.12, 440.12, article 440.12, it says 115 times the nameplate full load current shall be at least 115 of the nameplate rating load current of the second blah blah blah, whichever is greater. So I have 1.15 1.15 times 28 and 1.15 times 33. Who's going to give me the answer for this?
32.
The first one? 32?
Yeah.
32. Second one? 38. Okay? Let's make this all disconnect. Disconnect. All right. What was the DeWalt that I gave you guys for the disconnect? Before? DeWalt size 3.12. You go to 3.12, what size disconnect you're going to have for this boy? I can tell you it's 60 amps. How about this? 60 amps. Where did you get this, Chad? Not from my basement. From DeWalt 3.12 or -12. Okay. That's a piece of a cake.
That last system was 3-phase.
No, single phase. All of them are single phase. These are for 3-phase or single phase. The disconnect.
Oh, I'm just asking about the 60.
60, this is a single phase. Okay. Right? Do they have, these are disconnects for, they don't have, the sizes of disconnects does not have, oh, doesn't matter right here. Are you looking at fuses maybe?
I was just looking at here. I just wasn't sure we got the whether it's single phase
Yeah,
or
30, 60. You can buy a 30 amp single phase or a 30 amp single or 3-phase. Yeah. Okay, so that's number one. This is number one. Number two. Number two, my friend, is what's number two, DJ?
Two is the overcurrent protection device.
Overcurrent protection device for the branch circuit. Okay, if you guys go for this one, you need to go to 440.22. 440.22 and also 240.6. If you go there, it will tell you first 175, then it goes again, it tells you 1.25 if it doesn't start. Always start 2.25. Start always with 2.25. So 2.25 multiplied by 28 and 2.25 multiplied by 33.
You're going right to the 2.25?
Right to the 2.25. Assuming it's not going to start and we go down. You can't go 175. You have a problem, Holly, or?
No, I'm just considering it the other way.
175?
Say if it doesn't
Yeah.
start.
If it doesn't start, it allows you, we're assuming it's not going to start, and we're going to go to the
Okay,
max.
so you're saying it's
What's the calculation, Brooks? The first one is 63 amps. The second one is 74 amps. If you guys read there, it tells you, these are obviously not standard, so your three options of going to the bar, crying, and custom design 63 amps, or go down, because it doesn't ask you to go up. So what's the next standard down from 63? 60 amp. How do you know where they are? From 240.6. Okay, how about 74? Do we have a 70 amp? Do we? Okay. 70 amp. Do we have, that's it. Okay. What else, DJ? Where are we now? 3? Conductor. What do we say? This is branch circuit conductor. Branch circuit conductor, gentleman and lady. Branch circuit conductor tells you 440.32. 440.32. And also 310.16 under 75-degree column. Always assume it's motor, always assume it's 75-degree column. Okay, it says 1.25 times the nameplate current, 1A, 1.25 times 33. Okay, what's the first amps? I can't hear it. 35 amps. Second one? 41 amps. Okay, now these are meaningless unless we convert them into dollars, which is AWGs. What's the 35? Can I get with number 10? Under 75. Don't forget the 75. Number 10?
10.
Number 10? How about 41? Can I get away with number 10 or do I have to go to 8? Have to go to 8. 8. Number 32. Can I get away with 12 or do I have to do 10? Oh, where am I? 10? No, sorry. No, never mind. I thought this is 32.
What do you gotta do for the 75?
Any question, guys? So it's straightforward, right? Number 4, DJ.
We didn't hit all 4.
Feeder, conductors.
Oh.
Feeder, feeder conductor. For feeder conductor, guys. Feeder conductor. Did we say feeder conductor? You're going to go to 440.33. 440.33. If you read through 440.33, it will tell you 25% times the largest motor plus all the other boys with it. Okay, piece of cake, Chad. Does that sound like motors? 1.25 times the largest motor. What's the largest motor? 33 plus all the boys and the girls sharing the feeder. 28. What would that give you? A healthy. Don't forget that you have to put the brackets here. First you multiply, then you add. Can't believe how many people add them and then multiply them. Don't forget that we have to go also to 310.16 under 75-degree column. What did you guys come up with?
69.
69 amps. Convert this one into dollars.
Number 4.
Number 4 under 75.
Mhm.
Number 4. How many conductors, number 4, do I need for a two-phase, single phase? 2. Okay. The last one, guys. DJ, my friend, number 5.
Feeder overcurrent protection device.
Feeder overcurrent protection device. For this boy, you need to go to 440.22. In particular, B. In particular, B. If you guys read through B, that one here, we went here, 440, that was an A. We went to 440.22A, and the last one, when we calculated the branch circuit, we went to A, guys. When we calculate the feeder, we went to B. If you read through, it says the overcome protection, the same thing like motor. The largest overcome protection device of the system. What's the largest overcome protection device of a system? 70 amp. plus the full load current of all the others. The largest overcome friction device of a system, 70 amp, plus the full load current of the others, 28. That will get you 98 amps. And if it's not a standard, by the way, Chad, you need to go to 240.6 to find the standard. If it's not standard, what do you need to do? Doesn't allow me to go up. You're gonna go down. What's 98 down? Do we have 90? 90. Any question, guys? You can't read it. You can't.
I'm having trouble seeing where you're getting that from.
Okay.
I'm
Look.
on 430 and 440, 22B.
Okay. Look at 1. Did you read 1? Read 1. It refers you to 440.22a. What does 440.22a tell us? How to size the overcome protection device for the branch circuit, right?
Yeah.
So that's what they're referring you to, the branch circuit overcome protection device plus the full load current of all the others. They're telling you, go to this, pick whatever you get out of this calculation, which we found the largest one, which is 70,
Right.
and add the full load current of everything else to it, which is the first one. They keep plus the sum. Now the 60. 70 here plus 28. That's why they use the term branch circuit selection current or rated load currents. This is just, think of it as a full load current. They keep playing with these terminology, rated and branch circuit. They have two terms that they use it. What's coming when we use, I don't want to get into it now. We'll get into equipment, HVAC equipment. We study these terminology that comes with them. But for all practical reasons, you can think of it as a full load current of the equipment, and you're good. Any question, my friends? DJ, did we miss anything, bud? Guys, this is all what you have to do in chapter 7. Really easy, 2 examples. That's it. This is recorded for you and will be PDF'd. Any question before I sit down? You can't ask me if I sit down. And